All right.
Okay, so now we're going to cover area between two curves. So what you first have to do, and it's highly recommended all the time, make sure your equations are in the simplest form to use. We purposely made these annoying just for you to figure it out. So if you can't tell, f of x is equal to e to the raised to the 2 pi I times 4 minus x squared. To simplify that, you would have to know that e to the 2 pi I equals 1. So this ends up equaling 4 minus x squared. So, and then this bottom one we made even more demonic. We have 2 to the ln times 2 times ln e all to the third times 6 times 1/2 x plus 1. This would end up all over 2 to the third times 3 factorial. Factorials are as simple as they can get. It's that number multiplied by all the smaller numbers behind it, and 2 to the cubed is 8. Well, we know ln e equals 1. 1 times 2 is 2. 2 to the third cancels with 2 to the third. And since we know 3 times 2 times 1 equals 6, 6 cancels with the 6 on top. And you simplify the equation to equal 1/2 x plus 1. Goodbye, little cap. So next step is to graph your graph. And you can just do a rough sketch. It doesn't have to be perfect curve, perfect slope the whole time. So let's do that. It's nice and big for everyone. So label your axes as always. So now we're going to just draw the first one. F of x equals 4 minus x squared. So since we know it's a negative parabola, just draw a nice, like that. Probably could have made that a little higher up, but life will move on. The next one is a linear graph, 1/2 x plus 1. So you're going to draw something like that. Doesn't have to be perfect, as I said. I'm a terrible artist because technically there's no gap there. It just crosses like that. Terrible artist. So now we'll go on. The next step is to shade the region between the two curves so you know what you're finding for. Some people might mistake that you're looking for this area between this and the x-axis, but you're not. You're after between the top curve minus the bottom curve, which is this area right here. Right there. So, in order to do this, you need to understand the concept of top minus the bottom. And if you know that, you can always figure this out. So our top curve is f of x, and our bottom curve is g of x. So the next step you do is you put that in the integral, because that's how you get area. So you would do the integral. Of course, we need our limits, and all you do is get on your calculator, graph the two graphs, find where they intersect. We did this ahead of time, so what you get is -2, 0, and the other point is 1.5 and 1.75. And that's from there to there. So with that, and since we're dealing with x, not y, you'll learn the importance later in the next section, I guess, is what you would call it. So, sidetracking. What you would do now is you would take your points of the x only, so only x, not ignore the y ones for now, and you would put these in your limits. So you have -2 to 1.5. Next, you would take your top equation minus your bottom equation. And since I don't feel like rewriting out these two small equations, I'd rather write f of x minus g of x. Now, when you put this in your calculator, you should have a function in your calculator under math. Some calculators, it's math 9. If you click math 9, you're going to get something that looks like this, FNINT. With that. What you do from there is you put in your function first. So we're going to put in the function. Next, you put in the variable you're using. In this case, we're using x. Next is your lower limit, and then your upper limit. Sorry, ran out of whiteboard. And when you click that, you click enter, and it spits out a magical answer. Accept it. It's your calculator. It's always right, even when it's wrong. So what you're going to end up getting is a number around 7.146, and that's how you do this process. It's rather simple.